Good afternoon, everyone. As Evan said, my name is Albert, and I am delighted and honored to host this panel, which is ambitiously titled, What to Know About Zero Knowledge. But first, I need to apologize to all the cryptographers out there. Oops, we did it again. We took a term from cryptography and, how should I say it, expanded what it means. And I'm very sorry, even though it wasn't my fault, not even one bit. It's actually more of these guys' fault. But I apologize nonetheless. You see, as cryptographers so often remind me, this already happened with the word crypto. A long time ago, like 6 whole years ago, crypto used to mean cryptography. But now, it generally refers to a much broader set of things, such as cryptocurrency or just this kind of circularly defined quote-unquote crypto space. And here, in a case of history, if not repeating, then at least rhyming, something similar has happened with the term zero knowledge, or ZK. When I thought about this, I was like, it's almost like someone somewhere went through an escalating series of dares. Like, I dare you to hijack the meaning of the word crypto. Oh, you did it? Well, that was too easy because, the word cryptocurrency even has crypto in it. How about you do something really ridiculous, like take an objectively defined term such as zero knowledge and repurpose it to include stuff that is literally not at all zero knowledge. And so that is the first thing to know about zero knowledge. It no longer means zero knowledge in a technical sense only. Rather, zero knowledge, or ZK, has morphed into referring to just about anything that utilizes certain proof techniques that give you actual zero knowledge in some, but definitely not all cases. So to summarize, ZK used to mean zero knowledge, as in I am able to prove that I know something without revealing anything beyond that fact. But in practice, ZK now tends to refer to a broader usage of proof techniques that have some important properties. Now, what are these properties? A very incomplete list includes precision, correctness, and succinctness. For example, when ZK is used for privacy, that's an example of high precision because you can provide better privacy when you are more precise about what information is exchanged. And succinctness is another way of saying that in some instances, ZK is used as this compression superweapon. Now, compression is super important, especially in a blockchain context, because as we know, the cost of storing data can be quite high. And so that's why, for example, a ZK rollup doesn't actually provide privacy. Rather, it provides a more succinct guarantee of correctness. Anyway, enough about how I think about ZK. My thoughts are both surely flawed and incomplete, which is why I have these 3 fine gentlemen up here with me today. Gubsheep, Barry, Vitalik, thank you so much for joining. Every time we chat, I learn a ton and have a lot of fun, so I'm excited to have another conversation. I hope everyone here enjoys it as much as I will. So let's start with some introductions, specifically Gubsheep and Barry, since I figure people are a little bit familiar with Vitalik. Gubsheep, Barry, can you share a bit more about what you do on a day-to-day basis? Start with you, Gubsheep.
Cool. Hey, everyone. I'm Gubsheep. I work with the 0x Park Foundation along with Justin Glibbert and a handful of other folks. On the day-to-day, most of our projects are focused on some combination of what we call application-level R&D. And what this roughly means is trying to skate to where the puck is going on, if Ethereum/public blockchains/new primitives from applied cryptography get, let's say, 100x better over the next 2 to 5 years, what is that really going to unlock? So we help support this, relatively tightly knit, but, loosely associated group of teams working on anything from applications of zero-knowledge cryptography to crypto-native gaming, or what we're currently calling autonomous worlds.
Yeah, so I'm Barry. I work with the PSE team at the Ethereum Foundation, and basically we work on applying zero-knowledge proofs to achieve both private and scaling applications. So some of our projects include like zkVM. We also have some like private voting, some private coercion-resistant voting stuff. Yeah, that's mostly what we work on. I also work with other people in the ecosystem to build these tools out. I'm in fact having a lot of fun working with some of the people in 0x Park on several different things at the moment.
Yeah, speaking of which, one of the things I really love about both PSE and 0xPark is you both have a desire to solve what I would characterize as the actual problems, as opposed to settling for these like superficial or defensible solutions. And I've seen both of the groups, or really the collections of people, demonstrate this deep sense of responsibility for how to go about doing things and a willingness to prioritize this like collective good. So I just want to say on behalf of the broader ZK ecosystem, which, as I noted, we've kind of repurposed to mean something bigger now, we're really lucky to have both these groups, and thank you very much for that. And so on that note, let's dive in on the core topics here today. One way that I like to learn about a topic is to ask people who know more about that topic than me, which definitely includes all three of these folks here. I like to ask people what has been surprising to them, what has surprised them. And so when it comes to ZK, what has been surprising over, let's say, the last 3 years? It's been 3 whole years since the last DevCon. That's a long time anywhere, but especially in this space. And so, again, I'll kick things off with Gupsheep, but we'll kind of have an open conversation from here.
Yeah, this is super interesting to me because actually it was around the time of the last DevCon in 2019 that I was first getting involved in the space to begin with. And when my zero knowledge journey was first starting. And at the time, the thing that drew me in was basically a set of tools built by the folks at IDEN3, Circom and SnarkJS, which enabled for the first time browser-based proving and in-browser ZK applications that were, if not developer friendly, at least developer possible. You didn't have to roll your own cryptography for the first time. And the thing that's just been continually shocking to me is, and I mean, it was true at the time and it continues to be true today, is I think that a lot of people find zero knowledge to be a very scary term. It seems like, oh, this is moon math, this is something you need specialization in number theory to understand, but really there's just so many ways to get started with zero knowledge and so many things that you can build and contribute to depending on whatever level of the stack it is that you have expertise on. And the space has just been surprisingly accessible for both math and CS technical generalists overall. I'd say the second thing that kind of is very complementary to that is that as a result, the space has been moving much more quickly than we originally, or at least I initially would have expected. I know Barry has a lot to say about ZK EVM with respect to this, but I look at my old notes from 2020 or 2021 when I'm trying to flesh out what are some of the open application level R&D directions. And I remember last year I wrote something we had a student, Peiren, who built out linear regression inside of a snark. And we were thinking, oh, maybe 5 years in the future it'll be possible to put a neural network in the snark. And lo and behold, actually this past Sunday, which was not even a year from when I'd written that, we had 2 teams that presented on their work on building MNIST and various classifiers inside of the Halo 2 proving system. So this stuff just keeps accelerating and accelerating and accelerating.
Yeah, so thank you, Brian. Just to build on what you said, I think that on your first point about getting into the space, I think one of the most powerful ways you can get in now, because we have all of these high-level tools, you can black box out a lot of the crypto components. It makes it a lot more accessible. Okay, but to answer the original question, the thing that most surprised me was, for 3 years ago, I didn't really think that ZK-VM was possible. I thought that it was just going to be prohibitively expensive, and over the last 3 years, I've sort of learned that oh, well, actually there's a whole bunch of extra scope to kind of optimize and improve the way that we can arithmetize things. So that makes me very optimistic for the future when I think that we can do ZK-AVM now. And I the next set of things that are going to be difficult, like neural networks and private social graph proofs and things like that are going to be super exciting to explore.
Speaking of ZK EVMs, Vitalik, you wrote and classified them in a fairly recent post of yours, and I know you've got a lot of thoughts. How are you thinking about ZK EVMs and how they're going to intersect with the future of Ethereum?
Well, actually, so before I answer, I should mention there's one really important word that the crypto space has butchered that you forgot to mention, which is inflation. Remember how in good old traditional lands, inflation actually refers to changes in the price level of commodities in terms of an asset, and we just totally butchered it and changed it to refer to the total quantity of an asset. Yeah, that's us. We're great. So, but anyway, on the ZK EVM question, I think it's fascinating because like if we step back and just think about, like what is the ideal kind of technical vision of a blockchain? Like what would I, love to see Ethereum look more like 10 years from now, right? Like the kind of vision that I think I gave a couple of days ago is imagine a world where everyone, whether they're a validator or they're someone else, they run a node and they just run a node on their phone. So, if you want, you can even stake $1 million of ETH on your phone. And every 12 seconds, a block comes in, and that block contains 3.6 megabytes of data. And you download 3.6 megabytes of data because these days phone planes are getting faster and faster. And you hash it, and then you check it against one snark. That checks like 3 or 4 polynomial equations, and then that's it. You just know that the block is correct. All you have to do is just take 3.6 megs of data, download it, do a few hash it, do a couple of polynomial checks, and you magically know that this is the correct block, right? So in that kind of future, running a node becomes vastly easier. Ethereum becomes much more decentralized. It becomes like this very theoretically nice and clean system in a lot of ways. But in order to get there, like we would basically have to take the entire Ethereum machinery, both the consensus layer and the execution layer, and stick it inside of a snark. And this is always something that we've known is theoretically possible because ultimately everything is a polynomial. I'm a polynomial, you're a polynomial. But it's...
Polynomial is the next term we're going to repurpose, is what you're saying?
Exactly, yeah. So the problem, but the challenge in practice has always been how many constraints is it going to take? How much inefficiency are we going to eat? Is this actually viable? But since we saw Plonk in 2019 and we saw I think Plonk unlocked a huge number of things because Plonk was it wasn't just a protocol. It was this meta-conceptual leap when you could start separately thinking about which polynomial commitments do you use to enforce your polynomial equations, and how do you convert what you want to check into polynomial equations, right? And you can answer those two questions completely separately. And so you can have traditional Plonk with KZG, traditional Plonk with Fry and Starks. You could have Plookup with KZG, Plookup with Starks, and basically just research those two directions separately. And then we've just seen all of these amazing improvements. We've seen Plookup, which is amazing for solving pretty much all, or making pretty much all kind of all traditionally snark unfriendly computation into something that's maybe only medium snark unfriendly. And then a couple of other improvements, and then we've been seeing all this amazing work on ZK VMs, at the same time all this amazing work on compilers to try to make it easy to compile things. And then at the same time there's a whole bunch of companies that are quietly working on ZK EVM ASICs. I'm kind of hoping that now that mining is gone, the miners are going to retrain and become developers, literally. And we're going to have amazing companies that are going to create super fast ZK proving hardware, and maybe in 5 to 10 years we'll actually get there, and you'll be able to run a full node on your phone and stake as much ETH as you want, and just download 3.6 megabytes, hash it, and check a couple polynomials, and you got a good block.
We will have some time for predictions. So I'm excited to hear what you actually want to put your foot on the ground for when it comes to what miners will do in the future. That's an area that I don't think I've heard much from before.
Okay.
And I guess building on this, a natural question for myself, and I'm sure many of the people in the audience, how do you all see ZK complementing the future of Ethereum? That can mean a lot of different things, so I'm going to throw this out there, and whoever wants to kind of run with it, please do.
One of the ways I think about for why ZK is a natural complement to blockchains is that blockchains give you censorship resistance and guaranteed execution and a couple of other guarantees, but at the cost of two really important things. One is scalability, the other is privacy. Well, what two properties are ZK snarks exactly tailored for? Scalability and privacy, right? So it's they two almost fit together perfectly, these pieces of a puzzle, and one just completely solves the weaknesses of the other. So I think they're a perfect fit, and there's a lot of applications where if you only have one, they don't make sense, but if you have both, they just suddenly start fitting together.
The way that I think about this is that blockchains are creating these massive data sets, and these data sets are available and public, and there's so much rich information that's going to be there. It's going to be very, in order to allow people to make like proofs about this information, you need privacy and you also need succinctness. So like there's some things that we can do already, like we can use tools like Semaphore and Hanon to make proofs about like that you're part of a group. But like this data is so rich, and the way that it's rich is it has social connections and interactions. And like what I want to see us do in the future is to start to explore ways to make proofs about this kind of like shared network data that I don't know all the private information about, but I can work with a group of other people in order to make a proof, for example, that, oh, I am 2 steps away from a certain person in the social graph. That's where I see some really exciting things coming in the future.
And a neat thing that I'll say real quick about that is the basically fully transparent nature of a blockchain and its history. This has been one of those classic examples of something that in some contexts is a feature and in some contexts it's a bug. But it's neat that in this context, we're looking at ways to make it a bit more of a feature because like you said, it's an incredibly rich and verified data set, arguably the richest, most verified data set ever produced. And the ability to kind of work with that using proofs in various ways is just something that is going to be really interesting. And I think it's something that you've thought a lot about, so.
Yeah, maybe I'll give 2 framings for I think the equivalent concept, but from a slightly different angle, because I think that these are useful when thinking about like what kinds of applications might be powerful in the future. The first is, to dig into that complementary framing of what ZK and Ethereum have as a relationship. One thing that is interesting about ZK taken, just alone is that in some sense ZK proofs are stateless. So I can prove, for example, that I know the pre-image of a hash that is contained in a Merkle root, but why would someone care about that particular Merkle root, right? Like a common question actually that we get when we're introducing new developers into ZK is like, well, can I use a ZK proof to prove that I know some private key of an account at this block hash? Or like that I know some sort of fact about a smart contract on Ethereum. And the answer is, well, you can't do that directly because ZK proofs are just like mathematical equations. Math is not aware of the Ethereum blockchain. However, what the Ethereum blockchain does is it allows us to come to consensus on what's important, which I think is kind of like a little bit of the flip side of some of Barry and Vitalik's framing. So we imbue a certain Merkle root or a certain block hash or cryptographic accumulator with meaning, and that's what gives ZK proofs their power. That's what gives ZK proofs like their semantic meaning. And then the second kind of framing that I would think about is, this is to go off of Albert's comment, blockchains are, it's almost kind of like an accident that in order to build something like basically a consensus engine that we can all agree basically on a certain state root or something like that, all of the data has to be transparent. And I think that that's not necessarily that's not intrinsic, we can use these new tools like ZK proofs or witness encryption or whatever else to build systems where we can still come to consensus, but we don't have to make every single thing public, which is actually a really limiting thing in the design space of coordination mechanisms that you can build.
Yeah, can you expand on that a little bit? Because one conversation that we've had with, for example, various more traditional tech companies is this idea of making the data that they have, private in literally their databases available, but not available in the conventional, well, we just reveal all of it, because they're obviously not going to do that, but available in the sense of being amenable to proofs and other things that people can then use outside of those systems. Can you expand a little bit about how that might work, either at a high level, low level, really whatever is top of mind for you there?
Oh yeah, one thing that I think could be really interesting is what if we took, this is super blue sky far out, but knowing how fast ZK is going, maybe it's not actually as far out as we think. Imagine we took some traditional Web 2 social company that's got an account model, whether that's like Facebook or Twitter or Reddit or something like that. And on these services, maybe what we could imagine is the service provider would produce a state root for everyone's account. Now, it's not going to necessarily show all of the underlying data that is underneath the state root, because that might include your password or your password hash. But at the very least, what they might publish is a Merkle tree of a bunch of account state roots. Now, what you, the user, can do is your personal data is still private to you and the service provider, like whether that's Twitter or Facebook or Reddit. The actual data, only a hash commitment to that data is being shared. But you can start making ZK proofs that everyone knows are actually valid and are using an attested to data set. You're not making something up. So you can prove, for example, that like I am in this Facebook group, I'm in this subreddit, I have this reputation, maybe I can carry that reputation from one platform to another platform. And that I think is a really interesting like interoperability mechanism between the Web 2 world and the Web 3 world.
Yeah, and one thing I want to note about that is sometimes people hear this idea and they're like, yeah, but the company, they can just change their database however they want, so why is this useful? Well, if they publish a state root, they at least can't change things after that. And by the way, a very natural place to put that state root would be on a decentralized blockchain. So I think even though it isn't anywhere near the same as like the Ethereum blockchain's history, we still get something there that is, I think, quite interesting, and the ramifications of which we really haven't even scratched the surface of. I'm kind of moving forward here. Building on this whole, like, let's just talk about different topics, build up different vantage points to try to learn more about it. One game I like to play is what I call the underrated, overrated game, which is simply to say, what do you think is underrated in the space right now, and what do you think is overrated in the space? So maybe let's start with underrated, and again, I'll kind of throw it out there for anyone to pick up.
So I think that when we think about this question, we need to think about it in like different contexts. I think that like if we're asking this question in the context of like the Western world, that I think that in the Western world we tend to overweight the value of financial privacy, whereas like our societies are like for the most part free, and the most important thing about our societies tends to be like who speaks and who gets to be part of discussions and how decisions are made and how we decide what to do. So I feel like that's much more important than the kind of financial privacy applications. So in the Western world, I think that like private social media and things like that are much more interesting. In the developing world, it's completely different, right? In the developing world, it's just so important to have financial privacy that it's like, yeah. Like one thing that I kind of was really surprised about was we're running like a quadratic funding round at DEF CON, and like a lot of the people have like just serious problems with like private information, and they're just really reluctant to share that information. So yeah, that's what I think.
That's really interesting also because, and I think really fitting when you consider even this DevCon, where it's located, and a lot of the themes that have gone into it, which is when you try to say whether something is underrated or overrated, it's also by definition a matter of perspective. Where we're looking at things really affects things. A lot of times something is underrated or overrated because it's relative to something else that might be drawing more attention or not getting enough attention. Continue to love to hear other thoughts of like what's underrated or overrated when it comes to ZK.
Underrated is probably applications of ZK proofs in areas that have nothing to do with what we consider to be the traditional crypto space. So, government records of various kinds. I mean, the example of like proving things inside of social media applications, even games, like possibly supply chain stuff. Like there's just a whole bunch of areas where like maybe it also makes sense to put a blockchain in. Sometimes it does, sometimes it doesn't. But like even if it doesn't, it often makes a lot of sense to stick zero knowledge proofs in as well.
Yeah, absolutely. I think that's super underrated, at least from my personal perspective, which is a lot of what we're calling ZK doesn't require a blockchain. As we've noted, it's very complementary, but there's a lot of situations where you straight up are no longer constrained by operating on top of a blockchain, and as many people here are very familiar, I love the blockchain, but it can be quite constraining to work with at times. So that's something I think will also unlock innovation in new ways.
Yeah, I was actually going to jump off that as well. I think that a lot of times when we categorize ZK use cases today, well, first of all, there's a huge bias towards use cases that are related to the blockchain. Somehow these things have become, almost synonymous, like usage of ZK and usage of ZK on a blockchain. But the second thing is then when you dig into the categorization, we often break down apps into there's scalability applications and there's privacy applications. But I think that we're going to see a third category of thing that is like not quite either of those emerge in the near future, which is this idea of like ZK snarks as interoperability technology. And this might sound a little bit weird because interoperability is typically a word that we use more for, when we talk about smart contracts talking to each other. But there exists a rich set of basically cryptographic claims that actually, as a matter of fact, exists in the world outside of blockchains as well, whether that's, the signatures in your, GitHub commit history, or like the signatures that, various like communication service providers, whether that's like messaging services, email services, etc., use to authenticate your messages, or signatures on blockchains themselves. And one of the crazy things about snarks is that they turn these signatures into things that can talk to each other. So we move from this world where like the RSA signature algorithm can only be understood by other parties that are running, the RSA signature algorithm, to being able to put the RSA signature algorithm inside of a snark, which is sort of this like general purpose programmable cryptography construct. And you can do things like, I either contain this RSA private key to this GitHub account, or I possess this ECDSA private key to an Ethereum account. And you can start making these like cross-platform claims. And I think that that's something that's underrated and hasn't been thought about enough. And I know there's a number of like PSE and 0xPark teams that are thinking about these things that are actually going to demo this week. So if you want to check out Ayush's ZK email project, I think that this is a really, really awesome one in particular.
Just to build on what Brian has said, so one thing I think that is underrated in the space is that we're having a lot of social media experiments happening, and like I think that social media will make internet discourse become more collectivist and less individualistic. And like the reason that I think this is that because when you're part of a group, when you're making like private claims, when you're making proofs that you're a part of a set, when you make a post, you need to consider about the rest of the group, right? That like you tend to become more like protective of that group because you need to be careful about its perception and reputation.
You're like a representative of it.
Yeah, exactly. Yeah, so you speak more as part of the group as opposed to as part of from your own perspective.
So that's super interesting. What you're saying is because these technologies will enable us, for instance, to form these groups where we simultaneously kind of get to draft off of the reputation of the group, but then we also impact the reputation of that group. You think, or you can see how it will, for instance, make thinking more collectivist in certain situations. Is that about right?
Yeah, right. Because like I see today that like a lot of social media is very individualistic, right? A lot of people are focused on like more likes on Instagram or retweets on Twitter and things like that. And like that leads to these kind of incentives that are inherently about like performance. But when you switch the paradigm and instead of trying to get things for yourself, you're trying to gather things for your like group, the people that you're speaking as part of a set of, that changes the game completely. I'm really excited to see how that will develop.
Yeah, that's super fascinating. One other thing that always jumps to mind for me right now as being underrated, and I think you guys have a lot of thoughts on this, is just the kind of community and ecosystem that exists in ZK right now. What have you observed, and maybe even compare and contrast a little bit with, let's say, the more conventional crypto ecosystem, if it can even be called such a thing?
So a couple of things that I've observed is it tends to be that like people who are drawn to the ZK space tend to be like really technical and really just excited to learn things and do things. And that's really, really fun. The other thing that I've observed is that like I've seen like companies who are like competitors with each other, like working together so much to like train people and audit each other's code and things like that. And I think that that's just really, really great.
Yeah, maybe one thing also to jump off that last point that I see as like a difference between, I think this is like representative actually of applied crypto broadly, not just ZK crypto, and it's true of the best parts of blockchain as well, versus other industries. Is like there are natural I don't want to say like decentralizing forces, but maybe forces that encourage or incentivize like the free sharing of knowledge and information. Because if you're trying to get everyone on board with your protocol, whether that's a cryptographic protocol or a roll-up, what you really need is for other people to understand and trust your system. So you need to be permissively licensing your code, or at least, permissively licensing is going to be sort of the gold standard, because then you're going to get people digging into the actual intricacies and understanding, all of the subtleties and edge cases, but I think that's something that's a really powerful effect.
Yeah, one thing I was actually reminded of this morning when Danny Ryan gave his talk is he said that I had said, and I honestly didn't remember saying this, but I believe him. He said that I had said that crypto is this intellectual gravity well. That's something I've absolutely felt for many years, right down to the part where I literally, again, repurposed the word crypto there. The only other thing I've really seen in recent years that gives me that same feeling is what we are now calling ZK. It has a lot of these similar intellectual gravity well effects. And I think for better or for worse, like blockchains are inherently financialized. Like the very invention of a blockchain is kind of introducing this incentive dimension that's orthogonal to more conventional consensus theory and other things. Much of the core consensus theory actually existed well before blockchains did. So you can't get away from this financialized aspect of blockchains. And that's been great in many ways. I think that's actually really been a positive for a lot of the development interest in the space, but it also causes the attraction of like other forces and factors that, well, knock on wood, I think are a little bit harder to do in a ZK context, though I would never bet against the broader crypto space's ability to figure out how to financialize the hell out of something. But right now, we are in, I think, a bit of an oasis when it comes to just being able to intellectually pursue really interesting problems that are also very practically valuable. And hopefully we can preserve that for a long time, and hopefully it's something that other folks in the audience can kind of get a taste of in the future as well. I guess now that we've scanned the space and where it is right now in a bunch of ways. So the natural thing that I want to hear about is something I alluded to earlier, which is just predictions. Predictions could be about something that will happen tomorrow, a year from now, decades from now. But yeah, what are some predictions? Hopefully not putting you on the spot too much here.
So my prediction is that by 2040, someone will have won a Nobel Peace Prize for using zero-knowledge proofs.
Well, that escalated quickly. Maybe say a little bit more about how that might work.
Right. So basically, the way I think about this is that zero-knowledge proofs can allow you to have like private interactions with people, and that means that you're able to build trust in an environment where there is no trust. And it turns out that this is really important for like negotiations between people. So like kind of like the easy path to this that I see is that the possession of software bugs will become so serious that there will be this crisis, and in order to overcome the crisis, we'll need to prove to each other how many software bugs each like nation state holds. So they can use a zero knowledge proof to prove that they know a software bug for Ethereum or for Firefox. And this will be the first step in decommissioning the software bug arsenals that people have accumulated.
That's super, super interesting. Remind me in 18 years to check back on that, but that definitely got us off on a bang. Other predictions that come to mind from any of you guys?
Yeah, I have a few maybe that are less like specific and precise than Barry's, and hopefully, and unfortunately less like inspiring, galvanizing. But I think, in terms of like really large scale trends, I think that right now, and you can even see this reflected in the programming of this DevCon, this idea of ZK applications is being seen as almost like a product or application category. And my belief is that like these new cryptographic primitives are going to be so ubiquitous that in, say 20 years, it's going to be the case that ZK and similar primitives are just happening in the background. Like, we're not going to call things ZK apps in the same way that we don't call websites HTTPS apps. I think it's like an incoherent product category. You know, similarly to how we had a lot of folks calling websites .coms, or this idea of like the .com industry. We're going to move instead to this world where you have this like massive space of applications and coordination mechanisms that require information asymmetry, which turns out to be a really, really fundamental primitive. And how that information asymmetry is created is not going to be the focus. It's more going to be like, you know, much like today we have e-commerce sites or like storefronts or landing pages or browser-based games. These things rely on the existence of DNS or HTTPS, but we don't call them, again, .coms or HTTPS apps today.
One kind of medium-inspiring one, I guess, that's a little bit less intense than someone winning a Nobel Prize, but I think is still important to recalibrate our thoughts around, is that I think over the next 10 years it will become recognized that ZK snarks are at least as important to technology as blockchains are.
Whoa, that's I think that is, depending on your point of view, perhaps as exciting as the Nobel Peace Prize. Like, I think the Nobel Peace Prize is an amazing thing, but I'm also kind of curious to see if we can, you know, build up even alternatives or other, you know, other sort of recognition emergently. So you sort of alluded to this earlier with some of the complementary stuff, like how ZK complements blockchains. When you say as important, that also implies like, how do you think blockchains are important? You also talked about that. So maybe can you tie that together to help us understand it a bit more?
Sure. And so I think like you can look at ZK both as massively enhancing what blockchains can do, and possibly even being a necessary ingredient in blockchains, getting to like the real high scalability levels of high scalability that a lot of applications require. And you could also think of you know, ZK applications beyond the blockchain space, right? So for the first one, like we talked a lot about rollups, we talked about ZK VMs, we talked about you know, my dream for the look and feel of running an Ethereum validator in 2032. And you know, prototypes of this may even come much faster than 2032. I don't know. You know, these people are insane. But and you know, without this kind of technology, like it would actually take a lot more sacrifices to get blockchains to, you know, hundreds of thousands of transactions a second, right? So that's the first part. And then the second part is just you know, the kinds of things that ZK snarks would enable. Like, even if we just imagine a world where like blockchains as a technology don't exist and are turned off, and you just ask the question of like, okay, you know, the world is dominated by you know, Facebook and Google and you know, whatever stuff the Chinese government supports, and you know, we're stuck with that. But you know, how do we make at least some of these better, right? And it's well, you know, giving people privacy guarantees while at the same time being able to compute over information is huge, right? Being able to have financial systems that prove solvency to people is huge. Having social media systems where you can vote anonymously and actually have a credible guarantee that your vote is being included, or even just like a guarantee that, like, let's say, you know, instead of Twitter having some opaque proprietary algorithm, Twitter has an algorithm that's actually open source, and but then also Twitter actually being able to prove that it's following its algorithm. Like, that's huge, right? So even if we kind of, you know, turn off blockchains and just, you know, imagine like, what's the difference between a world with no ZK and a world with ZK? Like, it's really kind of epochal gains in, you know, things like privacy and just being able to have a more, you know, free and open and cooperative world in just so many ways, right? And then once you add blockchains on top, then, you know, the gains are obviously compounding.
Yeah, one thing I think is really cool is I think we're past the point where we're worried about whether blockchains are going to continue to be a thing, so to speak. But I remember even several years ago telling people, look, no matter what happens with blockchains, part of its positive legacy on the world is going to be that it really complemented and accelerated research and development in just cryptography, more advanced cryptography, which is really what ZK is kind of becoming this, like, again, like I keep saying, catch-all term for. But since we have a bit of time to like dig in a little bit more on the future, I don't know how far we can get in the weeds on this, but what are some of these other sort of ZK adjacent future technologies that might be interesting, you know, like homomorphic encryption or indistinguishability obfuscation, or just other stuff in that category. Anything that like jumps to mind is just like, keep an eye out. Maybe not too much of an eye out because we are pretty far from some of this stuff, but yeah, anything that hops to mind for you guys?
Yeah, so the way that I think about this is that, so my answer is MPC. And why I think it's so important is that
Sorry, can you say what MPC is?
multi-party computation. And the reason why I think this is important is that ZKPs let you make proofs about secrets that you know. And like, it turns out that there's a whole bunch of things in our world with secrets that only I know. Like I know my private key for my GitHub commit keys. But our world has much more private information than that, right? There's all, like the richest information is to do with like social networks and social interactions. And if we want to make proofs about that, we'll need to be able to make proofs about shared secrets. And that's what multi-party computation lets you do. It allows you to make proofs about shared secrets. So I think that we can leverage these kind of things to make this kind of like proofs of connection in social graphs where you don't know anyone's connections other than yourselves, your own.
Well, I think the big kind of prize of prizes in cryptography that it's worth talking about is obfuscation, right? Because obfuscation basically lets you turn a program into an encrypted program, but where you can run that encrypted program and it has the same outputs on the same inputs. But if that program, the original program's source code had secrets inside of it, the encrypted program would not let you extract those secrets. It would only let you just run the exact code on the secrets and the inputs and give you the outputs, right? So the reason, like, one way to see how obfuscation is so powerful is like pretty much any other cryptographic primitive can be done with obfuscation, right? So, you know, if you want to, let's say, make signatures out of obfuscation, right? Then the way that you would do it is you would, you know, say take any symmetric signature scheme. So, like, you know, take something where you just like generate a big hash and you know add the data to the hash, just like some really simple thing. Then you would take the private key, just like is the encryption key of that, and then the public key, well, you would stick the encryption, your key into the obfuscated program, and then you would set it to decrypt, and you just publish the you set it to encrypt, and you'd publish an obfuscated encryptor. Another one is zero knowledge proofs themselves, ironically, right? You'd basically just, you know, literally create an obfuscated program where you'd be able to just like stick in a piece of code and it would run that piece of code and sign it with a key that it has internally and give you the output, right? And that gives you possibly the best possible ZK snark because verifying it is super simple. To verify, you literally just verify one signature, right? And then you could do really fancy stuff on top, like, you know, you could make a encrypt data in such a way that that data can only be encrypted if someone gives you a proof that something happened on a blockchain, right? So the applications of that, like, you know, just multiply really massively. The problem with this kind of obfuscation, unfortunately, is that like we've only had the first formally proven candidates for this like literally 2 years ago, and they're just insanely high in their complexity at the moment, right? Like it takes there's like 6 levels of you know, protocols inside of protocols inside of protocols, and there's this big tower, and like actually running it would take, you know, like 1 billion years or something. And you know, the question is, you know, are the very smart people going to be able to like bring that down to the point where it's something viable 10 or 20 years from now? And like we'll see. I think if we get to the like something viable, then you know the results of that could be amazing.
Yeah, and what's going to be really interesting is to see, like you said, the rate of progress here. I remember myself, I think it was back in 2012 or 2013, before I was even interested in blockchains, I first got exposed to the concept of fully homomorphic encryption. I was visiting a former intern of mine who also went to the same university, and she described it as like, for example, say you have a keyboard, but it's built in a way where you press a key and the keyboard doesn't know what key you pressed, and yet like the right kind of keystroke registers. And then she was like, oh, by the way, we're only 11 orders of magnitude away from this actually being viable. I was like, hold on, did you say 11 orders of magnitude? She's like, yeah, 11 orders of magnitude. But you know, in the years that have passed, I mean, we've chopped that number down quite a bit. Depending on the context, we're anywhere from even 1 order of magnitude, but probably more like 2 or 3 orders of magnitude away. That's a lot of progress, and it's gonna be, like I said, really exciting to just keep working on this and seeing what we can unlock. And we've even seen some of that, I think, like with your experiences building in the browser today compared to 3 years ago. What are some of like the numbers or rough ballpark
Oh
that you've
yeah, I
seen?
mean, I think it's something like, it depends on how exactly you interpret all the different computational resources, but since 2018, we might say that we've seen like 3 orders of magnitude improvement in how large of ZK snarks you can prove in the browser, so.
Yeah, totally. To make that more concrete, some of the things I've seen out of 0x Park involve waiting for 45 seconds, maybe 90 seconds. Not perfect, but viable, right? Like you can see situations where someone would be willing to wait, 1 to 2 minutes for something, and that exact same thing 2.5, 3 years ago literally would have involved maybe 2 hours, or just actually would not have been computationally or feasible for other reasons in terms of like memory or things of that sort. So that's to give everyone a bit of a taste of kind of the direction we've been going in, at least in some subsets of this space, and hopefully that'll continue. Hopefully some of the folks in the audience can also get involved and help us with that. And on that note, a quick question, just like, are there good places to, quote, get started? It's always like a very tricky thing, even for crypto more broadly. But I know that you guys have worked on various resources. So are there any like just quick things we can mention here? And of course, if you really want to get more involved, you'll want to follow up more afterward.
Yeah, so on our end, one of our focuses is like education and community development. So we run these applied ZK learning groups, and we're doing our best right now to get all of those materials online at learn.0xpark.org. So that's, an effort by various like community members and volunteers. I think like Michael Chu and John Guibas are probably around here right now. So that's a collection of videos, articles, various documents that have exercises on how to just get started with like writing your first circuits.
Cool. So that's learn.0xparc.org.
Yeah.
Yeah, so the first thing I would recommend is to don't get intimidated by all of the moon maths, to black box things out and to figure out what something does, not how it does it. And you can use that to build a whole bunch of things. And as you're building those bunch of things, you can figure out how the thing does what it does. And like that's how I learned, and it was really enjoyable. The other thing that I would suggest people to check out is you can check out the privacy and scaling exploration team's website. It's appliedzkp.org, and we have a Discord there. You can join and chat and ask questions.
So that's appliedzkp.org.
Yes.
Yeah, I mean, there's I think a lot of different resources, and like for people with different like skill levels and like and different interests. Like there's environments now that are literally online, like zkrepo.dev I think was one, right, and where you can just literally go and like start writing the code for a ZK circuit and like compile it, and it just outputs to you a piece of Solidity code that you can then stick on. Well, these days not mainnet because it would be a bit too expensive, but the layer 2 or testnet of your choice, and you can actually kind of play around and see if you can make some simple application. So that's one way to learn for some people. If you want to get into the math, then the appliedzkp.org page has I think a lot of good resources. Zkp.science has a bunch. I mean, I have a bunch that I've that I've written. There's a bunch that the Starkware team has written. There's quite a lot these days. Like just sometimes it even makes sense to read like multiple explainers on the same topic so you can see how they fit together. Yeah, so depending on like which side of things you want to learn, there's like there's plenty of different resources for you.
Yeah, just one other thing I wanted to add, that like we've given examples of how you can join if you want to be a developer, but as we talked about earlier, like there's a whole bunch of like community and ecosystem and cultural things that are also super important, and like I'm not sure how to get involved in doing that. Like maybe you could join some of our like private social media experiments. There's Skitter and Heyanon, and yeah, you can find it on appliedzkp.org or 0xpark's website. Or you could explore running a quadratic funding round or things like that.
Yeah, there are definitely ways to get involved that don't imply you have to get into programming or math side of things, because the goal of all of this is to touch so much more than just those areas. And a really neat thing that's emerged literally since the last DevCon is some of these experiments that, among other things, just need and want more people to get involved and to participate in the networks that are being built. So I guess to kind of wrap things up here, we've talked about a lot of stuff here today. We've talked about big stuff, future stuff, some deeply technical stuff. But one of the things that I personally love the most about Ethereum is is that Ethereum has this quote unquote soul. And so I'd like to close with a bit more of a personal touch. We all started somewhere. We were all noobs and frankly continue to be noobs to this very day. Any just stories or even fun anecdotes from, when you first got interested in Ethereum, when you first got interested in ZK or anything else? Anything you guys could share?
Sure. So so in 2017, I think, I deleted my Facebook. And I deleted it because I was getting worried about the kind of surveillance state and the ability, not really surveillance state, but the ability of Facebook to manipulate me with ads and showing me happy memories and things like that. And when I deleted my when I deleted my Facebook, I didn't realize that. I kind of realized that at the time, but afterwards I felt this loss. I lost connection to so many people. I lost a social network that I'd been building for years, and that was I still feel that loss today. I don't know who I went to school with, how many kids they have and things like that. And I didn't realize that it was connected at the time, but soon afterwards I got really interested in Ethereum, and I tried to build a t-shirt cooperative. I wanted to build a way for people to pool their money together so they could get a bulk discount on purchasing cool and fun t-shirts, that there would be designers, and then they would get a bulk discount. So I'm I didn't realize that at the time again, but now when I look back, I feel when I lost Facebook, I sort of lost this community. And since then I've been sort of searching for one, and that's what kind of brought me to Ethereum.
Thank you for sharing that. I first heard the story very recently from you, and I was like, wow, I didn't realize kind of how deep, and it explains a lot of why you've had all these really fascinating and wonderful experiments in the social media direction. And it's also just a great reminder that, again, the goal, at least my goal and our goal here, is to utilize these technologies in a way where we can more precisely get what we want out of technology and social systems and things of that sort.
Yeah, I can give a story about how I first got involved in Ethereum. Albert was actually the one who brought me into the space back in 2018. And I remember I spent 2 months over the summer of 2018 just trying to go through and just understand what Ethereum was. And I just remember having so much trouble, and I was so frustrated. And perhaps this is either an indictment of the quality of educational resources at the time, but I think it's more an indictment of myself and my ability to onboard. So ever since then, education has been a really big focus for a lot of the communities, I would say, in the 0x Park ecosystem. And that's why, even just last year, how learn.0xpark.org got started was I was talking with Jeff Lau from ENS, who had done one of our applied ZK learning groups. And he had also expressed this similar sentiment about coming into ZK, and the both of us were obviously really glad that we'd pushed through that initial hump on the learning curve. In no small part due to the fact that people in this community are so welcoming and so willing to share knowledge. And that's, Jeff ended up playing a huge part in putting together a bunch of different educational resources. So I would say that if you're coming up to a new topic, even if you're scared or intimidated, I myself literally took 3 months to just get a picture of what Ethereum even was. Eventually I was I can't understand any of these blog posts. Let me just go to the yellow paper and try to read it line by line. And eventually we actually did end up putting together a series of resources to summarize all of that stuff that made its way up to ethereum.org, among other places. So, one, don't be afraid, but also two, right after you have learned a thing is also, I think, the best time to give back and really solidify those learnings by sharing them with other people.
Cool. And I guess I'll close this out with a much smaller, sort of just a cute story. When I first started following Ethereum, I mainly followed it through Reddit. And I remember, seeing this user, u/vbooterin, on Reddit, and it was really interesting. I was like, oh, this vbooterin fella, he seems really smart, but also kind and wise. And for, I think 3 or 4 months, I literally was just like, oh, vbooterin is probably some 60-year-old Soviet era programmer. And I was genuinely shocked when I discovered how old or how young Vitalik was. at the time. But yeah, it's just really funny and interesting to reflect back on. And in some ways, it ties into some of these other things, which is because in my case, I hadn't really bothered to go and learn more about the person underneath it. But it's a neat little snapshot of like, hey, you have this sort of identifier. And then they're just commenting. They're sharing information. They're sharing their thoughts. And I was like evaluating that and only that and drawing my own conclusions. And I think there are positive aspects of that we can pull into some of these like social systems and other things that we're trying to build. So on that note, just want to once again thank you, Vitalik, Barry, Gubsheep, and all of you for joining us here today. Hope you learned something, hope you enjoyed the conversation, and hope you enjoy the rest of DEF CON.